Okay, this is a video that I'm going to do as a try to help somebody on the forum here for electronics forum, the thread starter. I'm not going to give the exact name or anything, but I don't. But anyway, uh, he designed a circuit with an NPN transistor. Now I'm using a 2N3904, but he has. I'm using the same values that he's using here for the resistors and everything. And you're saying that you're only getting around 600 and about 620 milliamps, 0.62 milliamps. Wow, 0.62 milliamps. That's even smaller yet. And you're not understanding why you're getting it. And you said that you are breaking your circuit components, the connections, and you're inserting your ammeter in there. Let me show you what I'm doing here to get the current flowing for the collector current, and we're going to take a couple measurements here and verify to make sure that we're getting proper current through this resistor here. I'll show you what I'm going to do here. Oh, by the way, I'm a hobbyist. I'm not an engineer. I'm not involved in electronics anyway, but only as a hobby. So I'm going to help you on this as a hobbyist. Okay? Okay, let's get to work on this. Okay, what I'm going to do is I'm going to take a voltage reading across the collector resistor of 4.3K. I'm going to hook up a wire here. Now this is connected to my black lead going into my voltmeter, and I'm going to use my red lead on the positive side of the 4.3k ohm resistor, and I'm going to touch it here, and the voltage is reading about 5.95 volts roughly. Let me make sure I get a good figure. About 1.5 okay, we're looking about 5. We'll call about 5.8 roughly in that area there. Now let's do some calculations here. Okay, 5.8 volts divided by 4.3k ohms gives about 1.3 milliamps of current, and that's pretty much what we are designed as for, about 1 milliamp. So you are getting 1.3 milliamps. Now we're going to verify this. We're going to make sure. What we're going to do is we're going to take a voltage measurement across the emitter resistor now. So what we're doing is we're not going to break the circuit in any way. We're just going to take voltage measurements. So now I'll clip my lead, my black lead again. I will clip that to the ground side of the emitter resistor, and then I'll take a reading at the emitter terminal here and see what we come up with here. Alright, we got 0.59 volts, so let's calculate that now. 0.59 volts divided by the resistance is 430 ohms, I believe it is. 430 ohms. Enter. And we're getting about 1.37 milliamps and 1.34 in the collector, so we know that we're getting good base bias also. We're losing about 3, let's see, 1, 2, 3, 1.34, 1.37, about 3 milliamps, 1.3 milliamps in that area. But anyway, we are getting base bias current, and we are getting about the 1 milliamp region that we're looking for. So you are getting 1 milliamp flowing through your transistor as collector current, emitter current. And the base voltage, let's keep in the black lead connected to ground here, and we just take a base voltage reading here real quick, and about 1.23 volts. And I think that's pretty much what we were looking for on the base voltage. Okay, so what I'll do now is I'll put that on the oscilloscope and see what kind of waveform we can get on this. Okay, so far your circuit looks really good on the bias. We have good bias voltages according to your design, according to your calculations. And so now I have my signal generator set up here for 100 Hertz cycles, sine wave. Here's the input now. Okay, I have the input set for 0.1 volts and the output set for 0.1 volts. Here's the output. So I'm going to have to crank the output down here in the voltage now to about 0.5 volts. And so now we see that we're getting, there's your input and there's the output, so we're getting good gain right there already. Each one of these is 0.5 volts, so we're at 1 volt now, peak. Now I'm going with peak voltage. The output is 1 volt peak, and the input is 100 millivolts peak. So you got very nice amplification right there. There is no distortion at that amplification. Now I'm going to go ahead and increase the input now to 200 millivolts. Okay, looks good at 200 millivolts, and you got good waveform, 200 millivolts peak, and now we're going 0.51, almost 2, okay, 2 volts, 2 volts on the output. Let's go ahead and put that to 2 volts here on the there's the output set at 2 volts, so you got 2 volt peak, and the input is set at 0.1, so that's 200 millivolts input and 2 volts peak output. So you got very good amplification there at that point. Now we're going to increase the input a little farther now. Okay, here's what's happening now. Your output is distorting on the negative side, and the reason why is because this is a common emitter amplifier, and you're going to have distortion, or you're going to have inversion. And so if you look at your distortion on your output, it's on top because your input is distorted. All right. Now let's take a look at this. It is not your circuit design of the that it's running out of scale or anything, off the load line or anything. It's because your input is getting distorted. Now, if you can clean up your input voltage, your output should still remain clean. If your input was still clean through here and you're getting distortion on your output, then I would say that you're running on your load line too high or too low, depending on which part of the waveform was clipping. But you're not clipping on your output only, but it's your input that is causing your output to clip. So in order to fix that, you would have to increase the input impedance of the stage, and by doing that, then you would have less distortion on the input, and then your output should be cleaned up again. Let's see what we can do in getting the input impedance a little bit higher now, and see what we can do with that. Okay, first thing I should mention is I do not have any bypass capacitor across the resistor, and that's how I've built this circuit with no bypass capacitor, and that's why I'm getting a good output at 0.1 volts. My suggestion is that your bypass capacitor right here is what's causing probably a lot of the input impedance being low. It could also be overdriving your circuit as well, because now as your frequency increases, your capacitive reactance goes down more and more, and therefore the impedance across here goes down and causes the gain of the amplifier to go higher. Like I said, my suggestion would be remove your bypass capacitor. You don't need that in there. You can get what I was getting without no bypass capacitor. I was getting good amplification at 200 millivolts. Very good amplification. So try removing your emitter capacitor, bypass capacitor, rebuild it, retest it, and then let us know how it looks for you. Okay, thanks for watching. Bye.